Today, we will talk about distribution shape, but we're going to pay close attention to what standard deviation and mean is. The main idea for this lesson is that the shape, the shape of a distribution factor can be determined by two factors, which are the mean and the standard deviation. We will see what a shape of a distribution is in a second, but just keep in mind that the shapes that we're going to see, they can be determined by using two factors. We can use the mean and also the standard deviation to figure out the shape and how it's going to look like. So keep that in mind. Now, let's start with the shape of a distribution graph. In this lesson, or in this course overall, we are going to see three types of a distribution graph. The first one is a normal distribution. So we are going to see three types. So here, let's concentrate one at a time. This is called a normal distribution. Now, there are some key properties here for a normal distribution, and that is, in a normal distribution, it is symmetric. So it is symmetric. Now, what do we mean by symmetric? Symmetric is that if you cut this graph right in half, you can get the right side, and if you flip it to the left side, you're going to have the same shape. So imagine that we have the graph cut in half. Imagine that you graph this section and you flip it to the left side. You will obtain the same graph. So this is what is called for something to be symmetrical. If you cut it in half, you get the right side, and somehow you flip it like if it was a book. And notice that this section, when you flip it, is pretty much the other side of the graph. So that's what it means for something to be symmetrical. Or if you have taken geometry, if we say that it's symmetrical, if one side is the mirror image of the other. So, or one thing to keep in mind is that it's just some kind of a symmetrical mountain. So you go up, and then you reach a high point, and then you start going down. So this is something called symmetrical. But one thing that to keep in mind is that symmetrical, it's always somewhere in the middle. So notice that this is our x-axis. And notice that the graph reaches its highest point somewhere in the middle of the x-axis. The graph is not over here. Well, that's a bad graph. The graph is not somewhere over here. No, the graph is not on the right. No, the graph has this mountain peak somewhere in the middle of the graph. So if we have those characteristics, then we're going to call it asymmetrical. And because it's symmetrical, then we're going to call that a normal distribution. So this is one of the distribution graphs that we're going to see. Now, the second type of graph that we're going to see is something called skewed to the left. Now, we said that a graph is skewed to the left if the mountain, if its highest point, it's on the opposite, it's on the right side. So notice that if your graph it's increasing, but its highest point occurs somewhere all the way to the right of it, then we're going to call that to be a skewed to the left normal distribution. So it's kind of like the opposite. If the highest point is on the right, then that is skewed to the left. But now, what happens if your highest point occurs somewhere on the left side of the graph? So notice that here I'm just tracing what graph they're giving us. Notice that here that the highest point, it's occurring all the way on the left side of it. So that's the opposite. Then this is going to be called skewed to the right. So let's just review real quick here. If the highest point or the mountain is somewhere in the middle, then we're going to call that a normal distribution because it's symmetric. If the highest point was supposed to be a 2, if the highest point is somewhere all the way to the right side of it, then we're going to call that skewed to the left. and the opposite, which is the third type of symmetrical. I'm sorry, the third type of a distribution shape. We're going to call that skewed to the right if the mountain is occurring all the way to the left. So now that we kind of have an understanding as to the three types of distribution shapes that we're going to see, let's actually see how they can be determined. So one thing to keep in mind is, like it was on the main idea, the mean and the standard deviation can kind of give you the shape of the graph. So here we're going to see some examples as to what happens to the graphs whenever the mean and the standard deviation changes. So one thing to keep in mind is, well, first, let's start with the actual definition of what a mean is. Mean, you can think about it as the average value of a given set of data, or the center part of your mountain. The standard deviation, you can think of it as the standard deviation. The definition of it, it says the average distance of data points to the mean, or you can think about it as the measure of spread. Now, why do we call that the measure of spread? Well, you will see in these three following examples. Now, here we got three different examples. We got the first graph, the second graph, the third graph, and the fourth graph. We're going to see one at a time. So let's concentrate on the first graph. Now, again, here, these are the values that will give us this graph. So here, it says that the mean is 100. So that means that the highest point in our graph is going to be on the 100 value. So that's what it means for something to have a mean, or the average value of the given data. Now notice that here we have a standard deviation which has a value of 5. Now, one thing to keep in mind is that when in here we use this symbol, which is called a sigma. So here, when the sigma or the standard deviation increases, the graph, oops, becomes more flat. Now, what do I mean by that? Well, notice that here in example 1, this is just a random graph where the mean is 100 and the standard deviation is 5. So notice what happens to your graph where the mean is still 100, but now we increase the standard deviation to 10. Notice that we go from a higher mountain to something lower. So as, again, this is sigma, but this is the symbol that we use for standard deviation. When the standard deviation increases, the graph is gonna become a little bit more flat. So notice here that the standard deviation is 5, so we have some kind of a mountain. The mean is 100. Notice that here that the mean doesn't change. The only thing that is changing is 10. And notice what happens to the graph. Here, it was a pretty high point. Now if we increase the standard deviation to 10, it's still a mountain, but it's not as high as the previous one. So notice here in example 3, we're still talking about the mean to be 100. And again, the mean is the center of your mountain. So the center of the mountain doesn't change at all. The only thing that is changing from these three examples is just the standard deviation. But now here, the standard deviation is 20. And just like the small summary that we wrote here, if the standard deviation increases, then your graph becomes a little bit flatter. So here, note that this is still a mountain, but it's just becoming more flat and flat. So as we increase the standard deviation, your graph is going to be more flatter. So it's going to be flat. If we increase the standard deviation, it's going to become more of a line until it becomes a flat. And now here we have the three graphs at the same time. Notice that every single one of them has a mean of 100. The three graphs are right at the center, But here, this is how the graph looks if we have a standard deviation of 5 in blue. Notice that when we increase the standard deviation to 10, we still have that same mountain, but just it's not as high as the previous one. If we increase it to 20, then we have the red graph. Still the same mountain, but just not as high as the previous two. So this is one thing to keep in mind. The mean, it gives you the center of the graph, and the standard deviation, you can think about it as how spread your graph is going to be. So now, here's your entrance ticket. Just give your own definition for mean and standard deviation.